Okay, we are picking back up in lesson 6.5. Okay, yesterday we took our first look at solving radical equations, and we got through all but the last section. And this last section is the section where we have to start really considering extraneous solutions. We did a little bit of checking on some of them yesterday, and what that meant, that we had to check, make sure things worked. But this section, we really are going to want to check for extraneous solutions. I mentioned extraneous solutions yesterday. What are extraneous solutions? Yeah, solutions that don't work. They come out as a legitimate answer, but they just don't work. They're, in this case, they usually make the radical negative or something. Okay. So, as we look at example A, what was our goal yesterday on these radical problems? Okay, when there's one radical, get the radical by itself. Is my radical by itself here? No. What needs to move away from the radical? The minus 5. How do I move a minus 5?
Add 5 over.
You add 5 over. So now, I'm going to have the square root of x plus 7 equals, what is x plus 5? X plus 5. So, just like yesterday, isolate the radical. Step 1. Once that radical is isolated, what's my next step? To square it, right? To get rid of that radical, we're going to raise it to the power of 2. If I square the left,
Got to square the right.
you got to square the right. On the left, what is the square root of x plus 7 squared? X plus 7. Because remember, the square and the square root cancel each other out. On the right, what is x plus 5 quantity squared?
X plus 5. 2x, or x squared plus 25.
X squared plus 25.
X squared plus x plus 25?
It's going to be 25.
25 x squared.
Man.
Okay, so let me do this as a hint. And yes, Carolyn, you're on the right track. X plus 5 squared means x plus 5 times x plus 5. How do we multiply x plus 5 times x plus 5? FOIL. So it's not just x squared plus 25. There is a middle term in there. So, x plus 7. And then we are going to FOIL this right side. So FOIL first, x times x is x squared. Outside, x times 5 is 5x. Inside, 5 times x, 5x. What's 5x plus 5x? 10x. Plus 5 times 5. 25. Okay, guys. We just added in an x squared. Solving technique now. How would subtracting x and 7 over help me? I'm not disagreeing. I'm just trying to get it out. What's our goal here? Okay, yeah. Because this is a quadratic, there's an x squared there, and there's x terms. Our goal is to make the equation equal to 0. If we subtract that x and 7 over, my equation is going to be equal to 0, and we're going to hope we can factor, right? If we can't factor, we have to go quadratic formula. But we should be able to factor in what we're doing today. Okay? So, in order to move a positive x, we subtract x. In order to move a positive 7, I subtract 7. Which term am I subtracting the x from? To 10x. Where am I subtracting the 7 from? The 25. So now, on the left, I end up with 0 equals x squared plus, what's 10x minus 1x? 9x plus 25 minus 7? 18. Okay. So we're going back to first semester Algebra 2. It's also Algebra 1 stuff. Go for factoring today. I really don't think you'll see quadratic formula because that would result in decimals. Okay. So go for factoring, meaning 2 parentheses. X squared breaks up into x and x. What am I asking myself?
What?
Multiplies to be 18, adds to be 9. 6 and 3? Yeah. Okay. So we've got an x plus 6 and an x plus 3. I've got 2 parentheses, multiplying to equal 0. Watch my step. Sum equal to 0, right? Zero product property says if 2 pieces multiply to equal 0, one of them has to equal 0. So we set them both equal to 0 to find our possibilities. So x plus 6 equals 0, or x plus 3 equals 0. Solve those. What are my solutions?
X equals negative 6.
Okay. On the first one, subtract 6, and x equals negative 6. On the second one, subtract 3, and x equals negative 3. So I have solutions of x equals negative 6 or negative 3. Except, what do we need to do now that we're at the end? Check for extraneous solutions. Okay, the teacher in me is going to tell you guys, there are likely to be extraneous solutions when you had an x outside the radical that you squared. When we squared it, yeah, we squared this radical, but there's also this x outside of the radical. That tells me there's likely to be an extraneous solution. Okay? So, how do we check this? Plug it into the original equation before you squared anything. So if I put in negative 6, negative 6 plus 7 is?
1.
1. Square root of 1 is 1. 1 minus 5? Negative 4. Equals x. What's x? Negative 6. Does negative 4 equal negative 6?
No.
Okay. Negative 6 is an extraneous solution. We're going to check negative 3. We don't just assume. So now we plug in negative 3. Negative 3 plus 7, 4. Square root of 4, 2. 2 minus 5, negative 3, equals x. What was I plugging in for x? Negative 3. So does negative 3 work? It does work. Do not ever assume that because one solution works, the other one won't, or vice versa. Don't assume they'll both work, but don't assume they won't both work. You could go 0 answers, 1 answer, 2 answer. Okay? Questions on that one? Okay, example B. Square root of 5x minus 1 plus 3 equals x. You know better what you're doing this time? What's step 1? Okay, isolate the radical. Get the radical by itself. What has to move for that to happen? Okay, how do we move that plus 3? Subtract 3. So now I have the square root of 5x minus 1 equals x minus 3 is x minus 3. Is my radical by itself?
Yep.
Yeah, so what's step 2? Okay, once you have that radical by itself, square it. What is the square root of 5x minus 1 squared? 5x minus 1. X minus 3 quantity squared. You don't have to. If you can multiply that in your head without writing it out, I'm fine with that. What are we doing? Whether you write it down or whether you do it in your head. You have to do x minus 3 times x minus 3, right? So you are foiling. If you need to write it out, then write it out. If you don't need to write it out, that's fine. Just do me a favor. Don't tell me my answer is x squared plus 9. Because you're missing a piece, an important piece, right? So x times x is x squared. X times minus 3. Minus 3x. Minus 3 times x again. Minus 3x and minus 3x is going to make it minus 6x. And then minus 3 times minus 3 is plus 9. So make sure you guys are foiling. What's next? Okay. Move that 5x and minus 1 over to join the other side. We want to make this equation equal to 0. So since it's positive 5x, I subtract 5x. Since it's minus 1, I add 1. So minus 5x plus 1. I end up with 0 equals x squared minus 6x minus 5x minus 11x plus 9 and 1 is 10. What are we hopeful will happen? We're hopeful that this can factor. X squared breaks into x and x. What needs to be happening with my numbers? A product of 10 and a sum of negative 11, if you want to get particular here, right? They're not going to let you get away with it. Okay, guys, numbers that could multiply to be 10 and add to be 11. 1 and 10. If it multiplies to be positive, my signs have to be the same. And then since it adds to be negative, they are both negative. What do I do to finish this up? Set each part equal to 0. X minus 10 equals 0. X minus 1 equals 0. I end up with solutions of x equals 10, x equals 1. Am I done with this problem?
Check
for extraneous solutions. So if I put in 10, go back to the original problem. 5 times 10, 50, minus 1, 49, square root of 49, 7, plus 3, 10 equals, what were we plugging in? 10. So the 10 appears to work. Try 1. 5 times 1, 5 minus 1, 4, square root of 4, 2, plus 3, 5 equals, what were we plugging in? 1. So that 1 does not work. Okay. Make sure you're checking these answers. If I recall correctly, I feel like Math Excel gives you hints on certain problem, like check for extraneous solutions. Yeah. Okay. I could be wrong on that, but okay, let's do at least one of these bottom ones. We might just do one, and that way give you guys a little bit more work time that way. But we have to do at least one because what's changing up again?
There's another radical.
Yeah, instead of one radical, there are back to 2 radicals. Now, if you look on the front side of your notes from yesterday, we did one that had 2 radicals. What was the goal when we had the 2 radicals on the front side? What was the first thing we did? Yeah, we got them by themselves. We separated them. We put 1 radical on each side. Now, in that problem, that's all there was the 2 radicals. Different in this problem, there is also a 1. So that means one of these radicals isn't fully going to be by itself. And that's just how it's going to have to be. Okay? But you still need to separate the radicals. Get one of the radicals all by itself, and the other radical will have to be that 1. Which radical is going to be easier to move here? Yeah, let's move the minus square root of x. To move the minus square root of x, we're going to add square root of x. Okay. So on the left, we're left with square root of 2x plus 1. On the right, what is 1 plus the square root of x? Can I add those?
No.
Are they like terms? No. So 1 plus the square root of x is 1 plus the square root of x. I'm going to reverse it and say square root of x plus 1. Okay. I at least have one of my radicals by itself. If I have one of my radicals by itself, what's my job now? We're going to square it. If you square the left, square the right. Okay, what happens on the left when you do square root of 2x plus 1 squared? 2x plus 1. What about on the right?
1 squared.
How about if I write it out as square root of x plus 1 times square root of x plus 1? So what are we going to have to do here? You are foiling. Okay? I didn't say this is a pretty problem. There's a little bit of work with this one. So let's foil. Work with me here. So it's still 2x plus 1 equals. Okay, what is square root of x times square root of x? X, right? Because when you multiply a square root by itself, you get just x. Okay, that was first. Outsides. What is square root of x times 1? Square root of x times 1 is 1 square root of x. Insides, 1 times the square root of x. 1 square root of x. And last, 1 times 1 plus 1. What can I do on that right side? Yeah. Combine the like terms. So what is 1 square root of x plus 1 square root of x? I heard it. 2 square root of x, yes? So I still have 2x plus 1. I have x. 1 square root of x plus 1 square root of x is 2 square root of x plus 1. What do I still have hanging around? A square root. Okay, guys, so we still have a square root hanging around. Now, good news, we went from having 2 square roots to 1 square root. What do you think we have to do to get rid of this 1 square root? Okay. We're going to isolate it. We're going to go through the same process. We're going to isolate that square root and then square again. Okay? So the problem is, we had 2 square roots, but we also had an extra piece, and that made it a little more difficult. So if I leave this square root by itself, how do I move the x and 1 away from it? Subtract them. So we're going to subtract x from 2x and subtract 1 from 1. 2x minus x is x. 1 minus 1 is 0. Equals, what remains on the other side? 2 square root of x. Now, I'm going to go with that radical is isolated enough. Technically, we could go with the idea of there's a 2 out in front of it. I don't like it, but what am I going to have to do with that 2 if I move it? Divide it and create a fraction. Honestly, I would rather leave it here. And that's okay because it's being multiplied by that radical. We can leave it here. And I'll show you what happens. So, if my radical is considered isolated, we're going to square both sides. On the left, what is x squared? X squared. Good answer. On the right, what is 2 square root of x squared? Okay, 2 times 2 is 4. And that 4 is outside the radical, right? So it's just a 4. What is square root of x squared? X. So how about if I say 4x? Does that make sense? We haven't thought like that very much, so I know it's different. Okay, guys. I have an x squared term, I have an x term. I can't square root right here. If it was just x squared equals 4, I'm for it. Let's square root. But because there's an x squared and an x term, you can't do it. Go with the make your equation equal to 0, and our factoring is just going to look a little different. To make this equal to 0, I'm going to subtract 4x. X squared minus 4x equals 0. Okay. My other factoring today was product and sum factoring. There's only 2 terms. They both have something in common. Does that give you a hint? They both have an x. So we can factor out a GCF of x. So factor out an x. I'm running out of room here. It's x times x minus 4. Do you see 2 pieces I can set equal to 0? There's x times x minus 4. What are the 2 pieces I can set equal to 0? Yeah. X equals 0 or x minus 4 equals 0. What does that make my answers? 0 and 4. Final step. Plug them in, check them. Let's plug in 0. 2 times 0 is 0 plus 1, 1. Square root of 1? Square root of 1 is 1. Minus square root of what number was I plugging in? 0. Square root of 0 is 0. What's 1 minus 0? 1. So does 0 work? Okay, let's check 4. 2 times 4 is 8 plus 1, 9. Square root of 9, 3. Minus, what was I plugging in? 4. Square root of 4, 2. 3 minus 2, 1. What just happened? They both worked. It is 10:47. Are you guys okay if I say you guys can have work time and we'll skip that last one? Okay. So, I expect to see you guys working. You've got about 15 minutes. Use it. Get started on your Math Excel assignment, which is Lesson 6-5.